Hello friends, welcome to PharmaGrid. So today we are going to discuss some calculations. Okay, calculations related to dilution mixing, and we will do calculations using alligation method as well. So let's discuss the first question. How many parts of 90% solution and how many parts of 50% solution is required to prepare 80% solution? Okay, so this types of calculation involves mixing of two similar preparations but of different strength to produce a preparation of intermediate strength. So in this type of calculations, we are mainly using alligation method. Okay, alligation method. So this is how we will do the alligation method. First, we will write the higher concentration. Then we will write the lower concentration here. And here we will write the required percentage. Okay, required percentage. And here, okay, see the arrow. Required percentage minus lower concentration. And here, higher concentration minus the required percentage. Okay, so this is how the method by which we are doing the alligation type of calculations. Okay, alligation type of calculations, or how we are using the alligation method. Okay, so let's come into this calculation. So in this question, higher concentration means 90 percentage. Okay, 90 percentage. So we will write the higher concentration as 90 percentage here, and lower concentration is 50 percentage. Okay, 50 percentage. And the concentration we need to prepare, or the required percentage, is 80. Okay, so higher concentration is 90, lower concentration is 50, and the required concentration or the required percentage is 80. Okay, 80. So see the arrow here. Okay, see the arrow here. That is higher concentration minus the required percentage. That is 90 minus 80 is equal to 10. Okay, is equal to 10. And here 80, that is required percentage minus lower concentration. That is 80 minus 50 is equal to 30. 80 minus 50 is equal to 30. So 30 parts of 90% solution. Okay, 30 parts. So this is the number of parts for the 90% solution. So 30 parts of 90% solution and 10 parts of 50% solution. And this is the required number of parts for the 50% solution. Okay, so this is the difference. Okay, see the arrows here so that it will be understood. So 30 parts of 90% solution and 10 parts of 50% solution has to be mixed to get 80% solution. Okay, so we got the answer. In the question, we need to find out the number of parts required for this 90% solution and 50% solution. So 90% solution number of parts is 30 and 50% solution number of parts is equal to 10. Okay, so the next question. Hydrocortisone 2% cold cream up to 60 gram. You have concentrations of hydrocortisone 2.5% and 1%. How many grams will you use from these two concentrations? Okay, so this question also we can do by alligation method. Okay, so here higher concentration is 2.5%. We will write it here. And lower concentration is 1%. And we need to prepare what? 2%. Okay, so this is the RX, or this is the prescription we need to prepare, that is hydrocortisone 2% cold cream up to 60 gram. So we have concentrations of 2.5% and 1%, and we need to prepare 2%. So 2.5% we wrote it here, which is the higher concentration, and 1% is the lower concentration, and by mixing we need to get the concentration as 2%, which is the required percentage. Okay, required percentage. So use the alligation method here. 2.5 minus 2, that is equal to 0.5. That is the higher concentration minus the required percentage. And 2 minus 1, that is the required percentage minus the lower concentration, that is equal to 1. Okay, that is one part. Okay, one part of 2.5% and 0.5 part of 1%. Okay, same as like that of the previous question. Okay, so number of parts of 2.5% hydrocortisone is one part, and 1% hydrocortisone is 0.5 parts. Okay, so the total number of parts is equal to 1 plus 0.5, that is equal to 1.5 parts. Okay, so the total number of parts is equal to 1.5. So 1.5 parts of the mixture contains one part of 2.5% hydrocortisone. Okay, so the total number of parts equal to 1.5, and out of this 1.5 parts, okay, one part is that of 2.5% hydrocortisone. Okay, so this part, that is, this part can be converted to gram. Okay, so this, which means 1.5 gram of the mixture contains 1 gram of 2.5% hydrocortisone. Then 60 gram of the mixture contains, because we need to prepare or the cold cream up to 60 gram. Okay, 60 gram. So find out the in 60 gram. Then 60 gram of the mixture contains 60 into 1. By cross multiplying, we will get it as 60 into 1 divided by 1.5, that is equal to 40 gram of 2.5% hydrocortisone. Okay, so we got the weight of hydrocortisone of 2.5 percentage hydrocortisone, that is 40 gram. So weight of 1 percentage hydrocortisone. Now we have found out the weight of 2.5 percentage hydrocortisone, which is 40 gram. Now weight of 1 percentage hydrocortisone. We already know the total weight of the mixture, which is 60 gram minus weight of 2.5 percentage hydrocortisone. We got it here. Okay. So the total weight is equal to 60 minus weight of 2.5 percentage hydrocortisone is equal to 40. That is 60 minus 40 is equal to 20 gram. Okay. So 20 gram is the weight of 1 percentage hydrocortisone. So 40 gram of 2.5 percentage hydrocortisone and 20 gram of 1 percentage hydrocortisone should be mixed. Okay. So this is the answer. So moving on to the next question, how much ictamol would be required to be added to a 5% weight by weight ictamol in yellow soft paraffin ointment to prepare 200 gram of a 17.5% weight by weight ictamol in yellow soft paraffin ointment? So this type of calculations can be done with the help of alligation method. Okay, so here 5% weight by weight. In the question we need to find out the ictamol or the amount of ictamol that should be added to 5% weight by weight ictamol in yellow soft paraffin ointment. 5% weight by weight means 5 gram is present in 100 gram. So here we took high concentration or higher concentration as 100% and lower concentration as 5%. And the required percentage is 17.5% because in the question we need to prepare 200 gram of a 17.5% weight by weight ictamol. So required percentage is 17.5%. So applying the alligation method, 100 minus 17.5, that is equal to 82.5, and here 17.5 minus 5%, that is equal to 12.5. Okay, 12.5. So total number of parts will be equal to 82.5 plus 12.5, that is equal to 95 parts. Okay, 95 parts. So as in the previous question, convert this into gram or express this in gram. 95 gram is present in 200 gram. Okay, because in the question they have given we need to prepare 200 gram. Okay, 200 gram. So here we got the total number of parts as 95. Okay, 95. So 95 gram is ictamol is present in 200 gram. Okay, 200 gram. So 12.5 gram contains. Okay, 12.5 gram contains x gram. Okay, so find out the value of x by using cross multiplication. 12.5 into 200 divided by 95, that is equal to 26.3 gram. Okay, so this 26.3 gram ictamol should be added to 5% weight by weight ictamol in yellow soft paraffin ointment to prepare 200 gram of a 17.5% weight by weight ictamol. So here the correct answer is option D, that is 26.3 gram. Next question, what is the concentration of the resulting solution if we dilute 100 ml of 5% antiseptic solution to 200 ml? Okay, this calculation we can use the equation C1V1 is equal to C2V2, where C and V are the concentration and volume respectively. So here C1 is equal to 5. Okay, C1 is equal to 5. First concentration is given as 5%. Then C2 we need to find out. Okay, because in the question they have asked us to find out the concentration of the resulting solution. So C2 we need to find out. Then V1 is equal to 100 ml. V1 is equal to 100 ml and V2 is equal to 200 ml. Okay, so all these values we know. C1, V1, V2, all these we know. We need to find out C2. So C2 is equal to, apply or substitute all these values in this equation. So C2 is equal to 5 into 100 divided by 200, that is equal to 2.5%, which is the concentration of the resulting solution. Clindamycin 1.5% weight by volume strength, dilution up to 300 ml. Okay, so this is the Rx we need to prepare. If you have 100 ml of 10% weight by volume clindamycin, how many ml will you use? That is, here we need to find out the volume. So we can use the same equation here. C1V1 is equal to C2V2. Here C1 is equal to 10. Okay, this is the solution or this is the concentration of the solution we already have. That is 100 ml of 10% weight by volume solution or clindamycin. That is C1 is equal to 10. Then V1 we need to find out. Okay, V1 we need to find out. C2 is equal to 1.5, which is the strength of the required solution or the strength of the required Rx or required prescription. So C2 is equal to 1.5 and V2 is equal to 300 ml. That is dilution up to 300 ml, which is V2. So substitute all these values in this equation. Therefore V1 is equal to 1.5 into 300 divided by 10. That is equal to 45 ml. So 45 ml is the required volume to prepare these RX or this prescription. So we have completed today's calculation series. Thank you everyone for watching this video. Please like, share and subscribe. Have a good day.